The research that I'm doing this summer involves looking into advancing the healing potential of soy-based wound dressings. What I'm looking at specifically is advancing the therapeutic potential by infusing these soy-based wound dressings with extracellular vesicles. I'm testing different sterilization methods for these films that we are infusing with the extracellular vesicles. I am looking into 3 sterilization methods using a UV light to cure essentially the powders before putting them into the polymer solution. The way that we are creating these soy-based protein films is a process called electrospinning. So electrospinning is how we are turning these polymer solutions into fibers that build up as a wound dressing. Essentially, you're using an electric field to turn a liquid polymer solution into solid nano-sized fibers. A big part of my research has just been learning how to electrospin itself. There's a lot of different parameters you have to play with, so the distance between the needle and the collector, how strong should your electric field be. What I'm taking from this research, and I can now appreciate more in class, is I have a better idea that what we are learning is directly applicable. Being in the lab, I can see the concepts that I'm learning, but also practice them in a new way. My project was initially to determine the shelf life of these extracellular vesicles in the wound dressings themselves, so in these films. But I quickly realized that that was going to be quite difficult because all of my samples kept getting contaminated. So we had to pivot a little bit, and I changed my project more to focus on the sterilization of these films instead of the shelf life. But it's taught me that research doesn't always go the way that you're expecting. You're gonna have a couple mistakes, things that you didn't expect, and you just have to plan and adjust and just be flexible. But it's all important and it's all interesting.